Biosphere is a zone of living organisms. Okay. So we saw what is biomass. It is the organic matter Sorry?
ನೀವು ಪಾಠ ಮಾಡೋದು ಅರ್ಥನೇ ಆಗ್ತಾ ಇಲ್ಲ.
ಅರ್ಥ ಆಗ್ತಿಲ್ಲ. ಏನ್ ಅರ್ಥ ಆಗ್ತಿಲ್ಲ?
ಏನ್ ಸರ್ ನೀವು ಬಾಯಲ್ಲಿ ಉಸಿರಲ್ಲ ಮಾತು.
ಏನಪ್ಪ? ಕ್ವಶನ್ ಕೇಳ್ಬೇಕಪ್ಪ. ನಾನು ಬಯೋಮಾಸ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಿದ್ದೀನಿ.
ಓದ್ಕೊಂಡ್ರೆ ಹೆಂಗ್ ಸರ್ ಅರ್ಥ?
ಇವಾಗ ನೀವು ಕೇಳಿಸ್ಕೋಬೇಕು. ಇವಾಗ ನಾನು ಕ್ವಶನ್ ಕೇಳ್ತೀನಿ, ಹೇಳಿ. ನಿಮ್ಗೆ ಹೇಳಕ್ ಬರ್ಲಿಲ್ಲ ಅಂದ್ರೆ ನಾನು ಹೇಳ್ತೀನಿ. ಬಯೋಮಾಸ್ ಅಂದ್ರೆ ಏನು ಅಂತ ಹೇಳ್ತಿದ್ದೀನಿ ನಾನು. ವಾಟ್ ಇಸ್ ಬಯೋಮಾಸ್? Biomass is obtained from living organisms. Living organisms ಅಂದ್ರೆ ಪ್ಲಾಂಟ್ ಮೆಟೀರಿಯಲ್ ಇಲ್ಲ ಅನಿಮಲ್ಸು, ಇದ್ರ ವೇಸ್ಟು ಇಲ್ಲ the plant material which is made up of which supplies us food, wood, the wood cut from the trees. All this can utilize to make the biomass. So the processes that are used to obtain bioenergy is digestion, burning or conversion. Digestion, burning, conversion ಬಗ್ಗೆ ನಾನು ಇನ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಸ್ಲೈಡ್ ಅಲ್ಲಿ ಹೇಳೋದು. ಇವಾಗ ಐ ಆಮ್ ಜಸ್ಟ್ ಟೆಲ್ಲಿಂಗ್ ಅಬೌಟ್ ದಿ ಇಂಟ್ರೊಡಕ್ಷನ್. I cannot speak in Kannada completely. I suppose there are many students from various branches. I mean various states. Not everybody understand Kannada, isn't it? How many of you are from other states? Can you raise the hands?
Excuse me, sir.
Yeah.
Sir, ಮಾತಾಡಿ ಸ್ಟೂಡೆಂಟ್ ನಮ್ಮವರಲ್ಲ ಸರ್.
ಹೌದಾ? ನಿಮ್ಮ ಸೆಕ್ಷನ್ ಅಲ್ವಾ?
ಅಲ್ಲ ಸರ್, ಅವರು ಯಾರಂತ ಗೊತ್ತಿಲ್ಲ.
ಓಕೆ. ಕಿರಿಕ್ ಮಹೇಶ್ ನಿಮ್ಮ ಕ್ಲಾಸಾ?
ನಮ್ಗೆ
ಹೆಸರೇ ಕೇಳಿಲ್ಲ ಸರ್.
ಕೇಳಿಲ್ಲ.
Who is this ಕಿರಿಕ್ ಮಹೇಶ್?
ಕಂಪ್ಯೂಟರ್ ಕ್ಲಾಸ್.
ಕಂಪ್ಯೂಟರ್ ಬ್ರಾಂಚಾ?
ಎಸ್ ಸರ್.
ನೀವು ಐ ಸೆಕ್ಷನ್ ನೀವು? ಆರ್ ಯು ಫ್ರಮ್ ಐ ಸೆಕ್ಷನ್?
ನೋ ಸರ್.
ಮತ್ತೆ ಯಾಕೆ ಬಂದಿದ್ದೀರಾ ನೀವು? ಬೇರೆ ಕ್ಲಾಸು
ಇದೆಲ್ಲ ಕಳ್ಸಿದಾರೆ ಸರ್.
ನೀವು ತಪ್ಪಾಗಿ ಬಂದಿದ್ದೀರಾ. ಯು ಡು ನಾಟ್ ಬಿಲಾಂಗ್ ಟು ದಿಸ್ ಕ್ಲಾಸ್. ವಿಚ್ ಸೆಕ್ಷನ್ ಡು ಯು ಬಿಲಾಂಗ್ ಟು? ಹಲೋ ಮಹೇಶ್. Mahesh, which section do you belong to? Kirik Mahesh.
ಮಾಡಿ ಸರ್.
ಏನಪ್ಪ? ನೀವು ಯಾವ ಸೆಕ್ಷನ್ ಸೇರಿದವರಪ್ಪ? ಎ ಸೆಕ್ಷನ್. ಎ ಸೆಕ್ಷನ್ A section is physics cycle, right?
Don't know, sir.
The class representative. Who is the class representative?
Excuse me, sir.
Yeah, Alex.
Sir, could you remove him?
Yeah, I will remove him.
Yeah, thank you, sir.
Okay, mute your mics, guys. Okay, let me continue with the session. I think he removed himself. Please pay your attention. Later you must find it easier when you are reading on yourself. That's the intention of teaching this subject. Otherwise, with little effort, with some effort, you can do good. So I was talking about biomass. Biomass is obtained from organic matter, like the plant material or the dead animal material or the waste of animals. All this makes up the biomass. The How can we get bioenergy from this biomass? We can get bioenergy by processes like digestion, burning, or direct combustion, etc. So those are the techniques that will be followed, which I'll be explaining in a different slide. Then this is a renewable form of energy. Why it is renewable? Because it doesn't get exhausted. As long as life is there on earth, it will be there. Hence it gives good energy security. It is causing far less pollution. It is economical. So what are the sources of biomass? This slide tells us from where all we can get biomass. We can get from animal residue, industrial residue, forestry crops, the dried branches, twigs, residues, all those things, agricultural crops and residues, the sewage supply, the municipal solid waste, the animal waste, all this are the sources of biomass. Traditionally, how the biomass has been utilized. If you look at the village side, they used to use this cow dung. They used to burn dry the cow dung and use it as a biomass. Even that was used as biomass, the animal dung or the cow dung. And it was also used as a fertilizer for good agriculture cultivation. And even the wood, they used to use the wood also, the dried branches or the fallen branches from the tree were used for giving warmth in cold climates and also to keep the wild animals away. The wood has been as served as a good abundant fuel for almost all parts of the country. Our country being a agriculture country where 70% is dependent on agriculture, we have a good supply of wood and it burns with much cleaner than coal. So this cow dung, like this, they used to make it into plates and then dry it and then use it for agriculture or use it as a biomass supply. So this is how the wood is stacked up and used for burning or cooking food. So now coming to the conversion of biomass into useful form. We have biomass feedstock, that is wood, agricultural waste and organic waste. Looking into this table, so this is the biomass source, the wood, agricultural waste, organic waste. This is called as the feedstock, that which is the initial input material. This is the initial input material, okay, and this is subjected to some conversion processes using certain technologies that are going to be followed, thermo or biochemical conversion techniques. Those techniques are direct combustion, that is directly heating it to give electricity or to produce steam. Then it is then there is a technique called as gasification, where producer gas is produced. Then we have pyrolysis and methanol production technique. In pyrolysis technique, we are getting charcoal or synthetic fuel oil. In methanol production, of course, we will get methanol. So in detail in the next slide, we will see how these techniques are going to be followed and how these techniques help us in the production of methanol, ethanol, biogas, or etc. gases, syngas, etc. gases. These techniques are called as thermo or biochemical conversion processes. End uses energy. End uses energy. We have to just get energy. That is the main intention of using the biomass. First conversion technique is the gasification. We are exposing the solid fuel to very high temperature and limited oxygen supply to generate a gas called as the producer gas. Producer gas is carbon dioxide. Almost nil supply of oxygen is given. There is no supply of oxygen, but it is heated. So this produces pyrolysis oil and phenol oil, leaving charcoal. This is the technique of pyrolysis. Next technique is digestion. Digestion involves the microbial activity. That is, we use bacteria in an oxygen-starved environment. You put it in a container, and after several days, the bacteria activity takes place. Without the supply of oxygen, it produces material called as methane. The next technique is fermentation. Fermentation technique, by this technique we get ethanol, and for this yeast is used. The microbe yeast is used, and ethanol is produced by this biochemical technique, in which sugars are converted to alcohol, like ethyl alcohol. More importantly, what is responsible for this biochemical process is the availability of zymase via yeast. Next is the solid fuel combustion, that is direct burning of the solid organic matter. Look at this. These are the plants, and after it dies, you cut it, you put it here, directly burn them, then it gives carbon dioxide. So this is directly utilizing the material. What is this gasification process? By the gasification process, we get a gas called as the producer gas. When we expose this biomass to very high temperatures and limited oxygen supply, we get the biomass, and this we get the producer gas, and this gas can be utilized for electricity generation. By we can run the turbine, and turbine can be connected to generator, and then we can get electricity out of the producer gas. So in order to produce this producer gas, what are the reactions that are involved? We subject the biomass to high temperatures. We subject the biomass to high temperatures with limited oxygen supply. Then we get a gas called as carbon monoxide, and that gas is called as the producer gas. This is gasification with oxygen. When it is subjected to gasification using carbon dioxide, we get carbon plus carbon dioxide gives 2 times CO. Carbon monoxide is again the producer gas. Or with help of water, carbon and water reacts to give carbon monoxide and hydrogen. So water means it is actually the steam that is prevalent, the moisture content, the at very high temperatures. So what does this gasification process involve? This block diagram here gives us a step-by-step. Yes?
We can't see your slide.
You cannot?
Sir, we are stuck in biomass sources. That's it, sir.
You're not able to see the slide?
No, sir.
Okay.
So we can see the slide of biomass sources.
Okay, got it, got it. You told me a little earlier, it would have been nice. Okay, that's okay. Now, are you able to see?
Yes, sir.
So,
Was it the same with everybody? Were you not able to see? Hello?
Yes, sir.
Yes, sir.
Yes,
Were you
sir.
not able to see
Yes,
the
sir.
slides?
Yes, sir.
Okay. Let me try to set it right. So this was the slide that you were able to see. Then I was telling how traditionally the biomass has been utilized. That is the direct burning of the wood or the cow dung, which is dried up and used for agriculture as a fertilizer, or it is also used for cooking also. And the pollution is also comparatively less when compared to fossil fuels. So this is how the animal dung is dried up and stacked up and utilized for burning, or the wood, the dried wood or the cut wood is utilized for cooking. So, and I was telling about the various conversion techniques. There's direct combustion, gasification, pyrolysis, and methanol production. And these are some of the thermo or biochemical technologies which utilize the wood agricultural waste, which utilize the wood agricultural waste and which utilize the wood agricultural waste, organic waste, to convert them into suitable materials so that we get useful gases like uh, producer gas or syngas or methanol, ethanol, etc. Like this, various technologies are applied on them to get the gases, and these gases can be used to run a generator, run a turbine, and then connect it to a generator so that you can get electricity, or you can use these gases to heat the material, heat any material, or it can be just used for the production of steam, or it can be used to run a boiler. So first of all, what is this gasification? Gasification is subjecting the fuel to very high temperatures with limited supply of oxygen. With limited supply of oxygen to generate producer gas. So the solid fuel is burnt at very high temperatures to produce producer gas. Producer gas is nothing but carbon monoxide. Then we have pyrolysis, heating the biomass in the absence of oxygen. Heating the biomass in the absence of oxygen to produce pyrolysis oil and phenol oil. The residue left is the charcoal. Again, charcoal again can be utilized for some useful process, like you can get electricity, or you can use charcoal for for some burning, etc. So digestion, next technique is digestion. Digestion means you have microbial activity. So if you think of digestion process in the human body, it also involves some microbial activity. Otherwise, the digestion is not possible. So as soon as we hear the word digestion, we can easily understand that there is a microbial activity in it. So digestion involves bacteria which work on a oxygen-starved environment to produce methane. Oxygen-starved environment. It works on an oxygen-starved environment to produce methane. The methane is the gas that is produced by digestion. Next, we have fermentation. From fermentation, we actually use the sugars. We use the sugars which are converted into alcohol, which are sorry, excuse me guys, sorry for the interruption. So I was talking about fermentation. Fermentation is the technique by which ethyl alcohol or ethanol is produced. It involves the sugars, like it can be a sugar cane or any some plant material which can produce sugar. So that sugar is converted into alcohol by the action of some microorganisms, usually yeast. So this ethyl alcohol or ethanol is also used in automobiles, can be used in automobiles or for cooking, etc. But the efficiency of the fuel is not that great when compared to the petrol that is being utilized. Then we have solid fuel combustion. That is direct burning of solid organic matter. Directly you burn them. You don't subject it to any digestion, fermentation process or gasification process. Just directly burning it like the wood. So this drawing here tells us that the material is burnt up like this, and it helps in the conversion of biomass to give some useful gases. So gasification process. By gasification, we have three techniques. One is utilization of carbon dioxide. Sorry, we utilize carbon dioxide or steam or oxygen along with the biomass material to produce carbon monoxide or carbon monoxide. Carbon monoxide is the gas which is also called as the producer gas, which is produced by exposing biomass to very high temperatures and limited oxygen supply. This chart here now tells us how the biomass can be subjected to various steps so that finally we can heat it or we can use it to run a boiler or generate electricity, etc. We will see how it is done. Initially here we are supplying biomass. We are supplying here biomass, and there is something called as a gasifier. I will tell you in a different slide about one type of gasifier called as the updraft gasifier. There are actually different types of gasifiers: updraft gasifier, downdraft gasifier, etc. In this gasifier, what happens is we are subjecting it to a gasification process, that is heating it to a very high temperature with limited supply of oxygen, and it helps the producer of the it helps the production of the carbon monoxide or the producer gas. And this gas is cooled. As it is cooled, you get some condensates, that is some remaining material. This gas is used after cleaning them. When you clean it, you get wastewater and condensates. This gas is used to fire the boilers. It is used to fire the boilers. From the boilers, you get some heat energy, which is used for the supply of heating, district heating, where heat energy is required to fight cold, etc. This heated gas can be utilized to run an engine, or it can be connected to a turbine or in turn connected to a generator to produce electricity, and this can be connected to a local grid, and then the electricity can be supplied. So the waste material coming out of it is used for wastewater treatment. Here we see how the gas is utilized to get electricity, or for district heating it is used. And here we see the waste material are utilized. The waste material are utilized for some wastewater treatment. Wastewater treatment. Again, the wastewater which is treated can be utilized for agriculture. The waste material can be utilized for agriculture. The wastewater can be supplied for canalization or for disposal. So coming to the first type of gasifier called as the updraft gasifier, I'm going to tell you about the updraft gasifier. So here updraft means you're supplying the biomass from the top region. You can see that the biomass is supplied from the top. Downdraft gasifier means the biomass is supplied from the downward side. So here the biomass is supplied from the upside, and it is subjected to some drying. It is subjected to some drying. It is heated. It is at about 400 degrees centigrade. It is dried. Then with no supply of oxygen and at high temperature, it is subjected to pyrolysis. Then it is subjected to a reduction process. Reduction means absorption of some material at 950 degrees centigrade. Then it is burnt, that is at 1300 degrees centigrade it is burnt to give out gases. Here we are supplying air for combustion process so that it helps in the combustion. Finally, here ash is remaining. We will see what is this updraft gasifier using a video so that you understand now itself what is the updraft gasifier. So let me show you the updraft gasifier. Give me a moment, guys. I think the volume is not coming. Let me show the updraft gasifier. So this will tell you how the gasifier works. Guys, are you able to see the video along with the volume?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Hope it is clear. I hope you have followed each and every step. Finally, the product that we are getting is the gas, okay, which can be used for generation of electricity or some heating purpose. Did you get it, guys? No, sir. I will supply these videos via Teams so that you can understand while you are learning, because I have just put the image of the updraft gasifier here. If you have to explain about it, then you need some reference. You need to just not depend on the notes. If you have to learn about the abroad gasifier or gasification process, especially for this particular slide, but I will try to see if I can supply any extra material on this. But currently, I would say that you look into the video that I am also giving. That will also help you in learning about the abroad gasifier or other technologies that we are going to discuss now. Next technique is the pyrolysis. Is the abroad gasifier clear to you all, guys? Hello?
Little bit, sir.
Okay, okay. Next is the pyrolysis. It is a technique where there is no supply of oxygen. There is no supply of oxygen, and it is subjected to decomposition of organic material at a very high temperature. And this technique in general is uncontrolled, meaning it leads to a variety of products, not just one product. As a solid material, you have charcoal. As a liquid material, you have pyroligneous oil, which is a mixture of chemicals like acetone, methanol, acetic acid. Then we get syngas, which is a combination of carbon monoxide and hydrogen. So you get from this pyrolysis, we get three types of products within the solid region, liquid region, and gaseous region. The next technique is the anaerobic digestion. Anaerobic digestion means there is no supply of air. Just by the word anaerobic means there is no air, but there is microbial activity. Digestion involves microbial activity. If we are utilizing bacteria to digest the biomass in an oxygen-free environment to produce a gas called as biogas, where the bacteria work together to break the biomass into break down the complex biomass, which might be the wastes or the plant material or the cow dung material or the wastes of animals, etc., which are subjected to some bacterial activity, resulting in the production of a gas called as the biogas. The biogas is mainly consisting of methane, carbon dioxide, hydrogen sulfide. So 50 to 75% is methane, and 20 to 40% is carbon dioxide, and hydrogen sulfide is 0.1 to 10 gram per millimeter, 0.1 to 10 gram per millimeter cube, and water about 5%. So these are the products that are available due to anaerobic digestion, and the calorific value of this anaerobic digestion is 16 to 20 megajoules per meter cube. Next technique, next slide is talking about biogas feedstock. What is the feedstock for biogas? Meaning, to get biogas, what is that is going to be fed to get biogas? Household waste, animal waste, agricultural waste, water treatment plants, waste of agriculture, waste of agriculture or agro industries. All this constitute the biogas production, or all these constitute as the feedstock in the production of biogas. The production rate, the rate at which the biogas is produced, depends on the type of feedstock used. The woody materials or straw kind of materials, they are very difficult to digest. So they can be subjected to some pre-treatment, that is cutting them using a machine and then supplying it for the biogas feedstock. The animal dung is easily digested and readily. But in the case of woody material, they needs to be chopped. So what happens in this biogas digester? Here we have, let's say we have cow dung. This is the floating dome biogas digester. Here in the mixing pit, we are supplying the cow dung along with water. It is mixed properly and is supplied here. This becomes the slurry. Here we have the partition wall. After several days, through this pipe you get the gas, and this gas can be utilized for electricity generation or heating or for some useful purposes. The waste material that is available is sent out using this outlet. So this is an anaerobic reaction. This is an anaerobic reaction for several days at suitable temperatures. We have to keep it to get the biogas, and this gas is a combustible gas. And this floating dome biogas digester is called as floating dome because it has a dome kind of a shape. If you look at here, this is the dome kind of a shape that is available here, because of which it is called as a floating dome biogas digester. And the digested matter is further used as manure. So I was telling about floating dome biogas digester. Next video I want to play is on thermochemical conversion of biomass to biofuels. I want to play this video today and end the session for today. I observe that this kind of theoretical notes is not enough. The videos might be good enough in your understanding. So hence I am playing this video now. Please observe it.
The thermochemical conversion process uses heat to break down biomass into intermediates, such as gas or bio-oil, that can be upgraded into fuel and other products. One type of thermochemical conversion process is gasification, a method that uses heat to turn biomass into a hydrogen and carbon monoxide-rich gas called synthesis gas, or syngas. This in turn is converted into liquid transportation fuels or other products. Gasification occurs at relatively high temperatures. Here's one example of a gasification conversion process. Wood material such as forest residue is a common feedstock for the gasification process. For best results, feedstock wood chips are no more than 2 inches in size and have 20% to 30% moisture content by weight, depending on the gasifier. In the gasifier, the biomass is broken down into vapors in a carefully controlled environment that typically contains oxygen and/or steam. The syngas produced is made up of carbon monoxide and hydrogen. Char, a solid byproduct of gasification, is typically removed using a cyclone. Cyclonic separation allows removal of particulates from a gas stream without a filter by using rotational effects in combination with gravity to collect the particles. Tars and methane are also produced. Their quantity and composition depend on the gasification environment. Tars are high molecular weight organic compounds. If they are not removed, these tars will contaminate downstream equipment and inhibit fuel synthesis. One way to remove methane and tars is by using special catalysts to convert the compounds into additional syngas, thus eliminating the methane and tar problem while also improving the efficiency of the process. Additional cleaning and conditioning steps may be required to remove other contaminants such as ammonia, sulfur, and carbon dioxide. The syngas is then conditioned to produce the desired ratio of carbon monoxide and hydrogen to achieve optimal chemical reactions in subsequent steps. The pressurized hot syngas is then passed over a catalyst to form a liquid. The catalyst is contained in a reactor, and the syngas is passed through the reactor, where the carbon monoxide and hydrogen molecules combine to form larger molecules. These molecules are subsequently cooled, condensed, and refined into clean, renewable transportation fuels and other products. The Department of Energy has supported development of innovative technologies that result in higher yields and superior quality of biomass syngas. These efforts have also resulted in a much more thorough understanding of the gasification process. Enabled by these advancements, industry is deploying gasification technologies that will bring clean, renewable transportation fuels and other biomass-based products to the marketplace.
So that's the end of the session today. So any doubts, guys? Dear students, do you have any doubts?
Sir, will you
No,
be
sir.
sharing us the notes, sir?
Yes, I'll put the notes today itself. I think you have the next session going to start. So stop the class today now itself. If you have any doubts, we can meet in the next class, which is on Saturday 9 a.m. Okay, guys?
Okay, sir.
Okay, sir.
Okay, sir.